we're going to write and draw the valence electrons for oxygen. Let's begin by drawing in our electrons and labeling some of the principal quantum numbers from the periodic table here. So we're going to find the box that oxygen is located in, right here, and we're going to fill it up with electrons, alternating the spin of our electrons every time. Now for this right here, this box is kind of, I wish this box was over here. Okay, so I've moved that box right there. Alternating electrons, up, down, up, down, up, down, up, down. I'm going to stop there because that's the box that neutral oxygen is in. We're only looking at the valence electrons, and we can see that there are 6 valence electrons. The first quantum number tells us the average relative distance those electrons are from the nucleus. So these dose electrons are closer, and these 6 electrons are relatively the farthest away. The second number tells us the shape of the orbital that electron occupies around the nucleus, and that's across the horizontal. Electrons that are in these blocks, they have an L equal to 0 or shape equal to 0, and we're more commonly going to refer to that as an S orbital or an S-type orbital here. This block over here is referred to as an L equals 1, and more commonly, for our purposes, calling it a P right here. Just for completeness, these are the D, or L equals 2. I'm not going to use them too much as metallic chemistry, not so much used in gen chem. So we're interested in drawing and writing the valence electrons. So let's kind of focus in on the valence electrons. They are the outermost ones. So I'm going to erase the innermost ones. I'm going to erase other things too, just to clean this up. I'm going to erase this comment about the D's. Okay. So those are the 6 electrons we're interested in drawing and writing out. Let's start with the 2s. The 2s electrons, that first principal quantum number is a 2, and the second quantum number L is equal to 0. And the M sub L, or the direction of that shape, is also 0 because the shape of an S orbital is spherical. So it has an M sub L of 0 because it is uniform in every direction here. Now the fourth quantum number is the spin. It's either +1/2 or -1/2. We've shown these with the 2 arrows here, up, one arrow being up, one arrow being down. To kind of draw that in here, I'm just going to do this. I'm going to put like that. Okay. So this is meant to be the 3-dimensional 2s orbital, and here are my electrons floating around in there. M sub s is +1/2 and -1/2. Those are my principal quantum numbers that I've written out. And here is my 2s orbital, and there are 2 electrons inside of that 2s orbital. So 2s2 has this type of shape. Those are 2 of our valence electrons. Let's draw the other 4 valence electrons. They are in the 2p shell. So let's draw out the 2p. And there are quattro electrons. Let's fill in 2p4. So n, the first principal quantum number, equals 2. P equals 1. Excuse me, L equals 1, which we refer to with the letter P. M sub L, there are 3 p orbitals. So M sub L, we need 3 M sub L values. Now they tell us the direction of the shape of the orbital. So the shape is P, which looks like 2 balloons tied together. And there are 3 different orientations a p orbital can take. One along the x-axis, px, one along the y, and one along the z. So we have 3 values for M sub L, one along the x, one along the y, one along the z. Let's draw those other 2 p orbitals. Now these 3 p orbitals, one is going left, right, one is going up, down, and then one is going towards the camera and behind the camera, like out of the board and into the board. So I have this kind of drawn at an angle like that. Only 2 electrons can fit inside of an orbital, and we have 4 electrons to play with. Now electrons are going to spread out like butter on toast. And for cartoon purposes, I'm going to spread my electrons first, alternating up, down, and only pair them when necessary. And again, these electrons have a plus 1/2, minus 1/2, designate M sub S number on there. Now, what is boxed out in orange, in my opinion, is the most accessible and useful things to be familiar with at this early stage in Gen Chem. Knowing how to identify these numbers, it's not useless, but we will use these ideas in the orange boxes to draw out bonds, sigma and pi bonds. A couple things about these images here that are bad and good. They're really bad in that they're static and two-dimensional. Now, where I've located the electrons is just arbitrary and just for cartoonish purposes. Okay, the electrons are moving 99% the speed of light, and they can move all around. Let me add a nucleus to these images here. This is the nucleus. So the 2s is surrounding the nucleus. This is the nucleus. This is the nucleus, and this is the nucleus. The electrons are not quarantined to this lobe. They can bounce back and forth and stuff like that and go everywhere and anywhere they need to because they're moving very, very quickly. This was trying to draw and write the valence electrons for oxygen. Thank you.